today I'll be talking about prefix, infix, and postfix. So this is the topic that will be used in ACSL second elementary division contest. So first we have to understand what is what is infix, because infix is just a fancy name for the notation that we use to write expressions normally. And by expression, I refer to a mathematical expression. So for example, 1 plus 2 times 3 is an example of infix notation, where you see the operand, which is the symbol that you use to denote what operation you're doing, is between the two numbers that the operation is being done on. So, when you're using infix, naturally you need to follow the order of operations, which maybe you know this by the acronym PEMDAS, like please excuse my dear Aunt Sally, right? Which stands for parentheses, exponents, multiplication, division, and addition and subtraction, where multiplication and division and addition and subtraction are on the same level, and you evaluate it from left to right. Right. So, um, an example is the expression above. If we want to evaluate it, we see that it has addition and multiplication. So first we have to do the multiplication. 2 times 3 equals 6. So the answer is 7. Note that the answer of 9 is wrong. 9 would be 1 plus 2 if you do 1 plus 2 first. That would be incorrect. But what about this? 1 plus 2 times 3. Clearly, you have to do the parentheses first. So in this case, 9 would be the correct answer. So this is a basic example of infix. So what is prefix and postfix? Prefix is a type of notation for writing expressions where the operation or operand is placed before the two numbers you're operating on. So for example, in infix you might have this 1 plus 2. But in prefix you would have plus 1 2. And what this means is that it's the same. The answer would be 3 when you evaluate it, but notice that the operand of plus is placed before 1 and 2. So let's do a slightly more complicated example of this, which we have. So let's look at the infix expression that we used earlier, 1 plus 2 times 3. So thinking about what order of operations does, if we put parentheses around what we have to do first, this would be the same as 1 plus 2 times 3, right? Because we have to do multiplication first. So we see that in prefix, something that we do first, I think so you would, when converting this to prefix, you would first take the expression inside the parentheses, since that's what you have to do first. And so you put the operand and then the two numbers. So this means 2 times 3. And then, so this part you have already converted to prefix. But now you want to convert the 1 plus part also into prefix. So you take the 1 and then the plus, and you put it like this. So this may look confusing, but if you think about it, it makes sense. Because you have plus 1, so you know 1 will have to be added to something, right? But instead of another number right next to the 1, you have another operation, which is the multiplication sign. So this means that you know that the 1 plus part will not be the part you evaluate first. Instead, you look at the multiplication sign and you see that it's a multiplication sign followed by two numbers. So you know that you have to evaluate this part first. And then after that, you would get plus 1 6. And you know this can be evaluated into 7, which is the same answer as what we got for infix. So this is a basic example of prefix. Postfix is very similar to prefix. It follows sorry, I forgot. It follows all the same principles except as the name implies, the operand is placed after the numbers. For example, if you have in infix you have 1 plus 2, then in postfix it will be 1 2 plus. Whereas in infix, you might remember that it's plus 1 2. So in postfix, the operand is post or like after the two numbers, and that's a way to remember it. So very similar to prefix, use the same principles to convert between infix and postfix. So for example, let's say we have the expression 3 divided by 3 plus 8 to the power of 2. And this symbol, I think in ACSL they use an arrow that points upwards. So it'll be like this. This means 8 to the power of 2, which is equal to 64. But ACSL will use this notation that you see here. So if we want to convert from infix to postfix, or you can also do this for prefix, follow the same steps. First, put parentheses to determine order. I think it's spelled like this. Okay, so let's take our infix expression and put parentheses on what we need to evaluate first. So 3 divided by 3, because of order of operations, we have to do this before the addition. And then 8 exponent 2, if you remember by PEMDAS, exponent is second. So naturally we need parentheses around that. So our newly parenthesized infix expression will look like this. And now we want to take the parts in the parentheses and convert them to postfix. Oh, and as a note, I believe ACSL will. Sorry, I don't know why it's glitched. ACSL will use the slash instead of division, so it would actually be 3/3, I think. So that's just a side note, I guess. So what you would have here is first convert this into postfix. So you'd have 3 3, and the operation slash is after that division, and then 8 and 2, so you'd have 8 2, and then after that. And then so now we know that these two parts are being added together, so we'd have naturally the addition after that. And you see these two postfix without using parentheses will automatically group the expressions that needed to be evaluated first together. And then you know that after you evaluate that, you would get 1 and 64. This would be equal to 1 plus 64, which would be 65. All right, now let's do some practice problems. And this is a problem from an ACSL practice test. So it's asking us to evaluate this following prefix expression. And even if it didn't tell you that it's prefix, you still know that it's prefix because the operands are before the numbers. So let's write this out. And this star, this means multiplication. The slash is division. So let's see what we can evaluate immediately. Since it's prefix, we're looking for places where the operand directly precedes two numbers. So that's here in these three spots. So let's evaluate this. 9 times 3 is 27. 8 divided by 2 is 4. And 5 times 2 is 10. So now we see that this plus will group these two numbers together. So you have negative 27 and 4, or minus 27, 14, which in infix would be 27 minus 14, which it leaves our answer to be 13. So now for another problem. Give me a second. Evaluate the following postfix expression. So again, let's write this out. And we can tell that it's postfix because the operands are after the numbers. Oh, and this is exponentation. I thought they used this, but I guess not. So just remember that this means that you're taking the exponent of something. Okay, let's look at what we can immediately evaluate. Also as a side note, in ACSL, you don't have, I think, in general, all the numbers used in these problems will be single digits. So you don't have to be worried that it is actually like 63 instead of 6 and 3. So it will always be single digit numbers that are being used in the given expressions. Okay, so now we've evaluated these three parts. And now let's look for where else we have two numbers and an operand. Sorry. So 20 minus 18 is 2. Seven to the power of 2 is 49. And this will equal to 50. And that is correct. Okay. Now let's try another problem. Translate the following infix expression to postfix. Okay, so the first step that you have to do is put parentheses around everything. Parentheses. I promise I know how to spell. Put parentheses around everything that you can using the rules from the order of operations. So let's write down the expression. 2 times 8 plus 5 to the power of 2 minus 9 divided by 3. Okay, so what will we have evaluated first? Well, using PEMDAS, there's no parentheses here. But then we'll have to evaluate our exponents, our multiplication, our division, and then now we're left with some addition and subtraction that would be evaluated from left to right. So something like this. And then next, you want to move from the very inside to outside of the parentheses to convert. So let's look at the very inside. So first we have 2 times 8. and that's in the innermost layer of parentheses, right? So then we'd have 2 8 times. And then you have 5 to the power of 2, so that would be 5 to power. And then these two things are being added together. So then you would have the plus, which would show that these two things are being added together. And now for the next part, 9 divided by 3 is also in the innermost parentheses. So we have 9, 3. And then our minus, which goes at the very end. So we can check this by converting it back to infix. So we have 2 times 8, 5 to the power of 2, and 9 divided by 3. And then there's a plus here, which means that it's here, and the minus here means that it's here. And this is the same as our original expression. So therefore, we know that our answer is this. 2 8 times 5 2 exponent plus 9 3 divide minus. Yep, that's the correct answer. So now let's do a slightly harder problem. This one involves fractions. And the special thing about fractions is that whatever you have on the fraction will automatically be grouped together. So if you wanted to convert this into like normal notation, it would be a to normal, this would be infix. But note that you have to put parentheses to group a plus b and c plus d. So our first step is to write this with parentheses and to write it in the normal notation, right? Because 4 squared, you can't just write it like that. You need to write 4 exponent 2. Okay, so what do we have? We have 4 exponent 2, and then you have 9 plus 6 divided by 5 plus 8 divided by 7 minus 5. Now to put more parentheses, we would need to put some around here and here. Okay, so now let's start converting. We want to convert to prefix. So we'll put it like this. And then, so this corresponds to this set of parentheses. And then this will be plus 9, 6, 5 divide. And then this will be minus 7, 5, 8 divide. It looks like pretty difficult but once you do some more practice, it becomes easier to understand. So now you'd be subtracting this and adding this, which at this stage it's pretty easy to do now. So for this, you just move the minus sign to the front. 4, 2, divide, plus 9, 6, 5. And then here you'd move the plus sign to the front. Divide, 8 minus 7, 5. So this should be your final answer. Let me check this with the answer key. Plus minus exponent 4, 2, divide plus 9, 6, 5, divide 8 minus 7, 5. Okay, this is correct. Alright, then let's do another problem. And this will be the last example problem that we do today. Here's the problem. Translate the following prefix expression into postfix. So I think it is definitely possible to go straight from prefix to postfix, but the easier method is to first go to infix. Oh, wrong color. especially at the elementary division level. Okay. Minus plus 9 plus 7, 4, 5. Okay, that fits. So let's convert this to infix. So first we look at where do we have an operand followed immediately by two numbers. So we change the expression into this. And then now what we have in the parentheses can basically be counted as one number. So then you'd have 9 plus 7 plus 4. And then now it's pretty simple to insert the rest of the operations. So this should be the correct infix expression, and now we want to convert this into postfix. And we already have the parentheses, which is nice. So let's go from here. And then divide by 5. So you would want 5 here. And then in here, you have 3 plus 7 exponent 2 multiplied by what's here. So it should be this. Let me check. 974 plus 5 divide 37 plus 2 exponent 8 minus. Okay. So thus, this is the correct answer.